All right, so this will be some trig examples for section 4.1. We're still just finding indefinite integrals. So for some of the trig integration formulas, so we notice we have cosine, we got sine, we got a cosecant, cotangent. There's a secant squared in there. Let's see, there isn't one specifically for tangent squared. At number 35, that one's going to be a little bit, I guess, not, well, yeah, I guess somewhat tricky because there's no integration formula from what we've learned so far that'll cover tangent squared. So I'm going to write down all the trig integration formulas I'm going to apply in these examples. So first one, cosine. So the integral of cosine is going to be sine. The integral of sine is negative cosine. Now notice for sine and cosine, we have the sign switches for the integration, whereas for the derivative, for instance, derivative cosine's derivative is negative sine, whereas derivative of sine is positive cosine. So the signs are opposite for the integration. All right, so there is a formula for cosecant cotangent. And let's see, so based on the table, that comes out to be negative cosecant. All right, so let's see. So there's a secant squared. So that should be tangent because tangent's derivative is secant squared. So this would be tangent. And there isn't one for tangent squared, at least not what we've learned so far. So there's not a formula for integrating tangent squared. All right, that's for at least what we've covered so far in this section. So these are the formulas I'm going to use, and now I'm going to apply these formulas to the particular question. But I figured I'd go ahead and just write them. If you want to pause the video, you can write down these integration formulas. Now it's just a matter of applying them to the particular questions. Okay, so 29, integrating 5 cosine x plus 4 sine x. I know in the last video I showed, now we can integrate each component, and I sort of skipped this step at some point because it just gets tedious to write it. You can break it up, so it's the integral of 5 cosine x dx, and then plus the integral of 4 sine x dx. Just reinforces take the integral of each component, and for each of these you can factor the value out. So you have 5 times the integral of cosine, and then plus 4 times the integral of sine. All right, so now it's just a matter of applying the correct formula. So for cosine, from the list of formulas, the integral of cosine is sine. All right, and then for sine, the integral of that's negative cosine. All right, the signs are switched for integration. Because normally when we take the derivative of cosine, it's negative sine, but when we integrate cosine, it's positive sine. And then plus 4, and then normally when we take the derivative of sine, it's positive cosine, but when we integrate sine, it's negative cosine. All right, and don't forget to attach the integration, constant of integration at the end, the plus c. So this would be 5 sine x minus 4 cosine x plus c. I will say, like from future videos, and actually for some of these examples, normally I would do the problem as the following. So normally I would skip some steps and work out the problem as follows. So I'll just write the problem over again. So I know I got to integrate each component or each term. And I know for the numbers 5 and 4, you basically factor that out in front of the integral of each component. And so for 5 cosine x, so I factor out the 5 and then I integrate cosine. And we just saw that when we integrate cosine, we get sine. So this would be 5 sine x. And then for integrating 4 sine x, we factor out the 4 and focus on integrating sine. And when you integrate sine, you get negative cosine. All right, so you see I skipped sort of some in-between steps, and then that gives me my answer, 5 sine x minus 4 cosine x. This is how I normally will do it. So essentially, I skipped this step, and I skipped that step. I didn't really actually skip it, I just talked about it. All right, and that's how I would do it, just to save paper or space. All right, so the next one's number 31. All right, so I integrate each component, right? So I integrate the cosecant cotangent piece, and then I integrate the negative 2x piece. I'll go ahead and show it for this one. So all the steps, so I break it up in the integral of cosecant cotangent. And then I have the integral of negative 2x dx. Now the negative 2x dx, I can go ahead and factor out the negative 2. And then I focus on integrating x. Now for the cosecant cotangent, that's one of our formulas. All right, so I look back and we had cosecant cotangent, that becomes negative cosecant. So that's negative cosecant x. And then I have minus 2 times the integral of x dx. And then from previous videos, there are multiple examples when you integrate like x to the n, you add 1 to its exponent, so it's x to the n plus 1, and then you divide by that same thing, 1 over n plus 1. All right, that's what I use. And then for x, it's the same as x to the first power, so I add 1. So it's be negative cosecant. Then keep the minus 2, focusing on integrating x. That's going to be x to the 1 plus 1, and then divided by that same thing, 1 plus 1. And then I'll add my constant of integration. So we have 2 over 2, because 1 plus 1 is 2, so I can divide those out. And that just leaves me with minus x squared. All right, so that's going to be my answer. And yeah, normally I would just go ahead and jump from the beginning to, so I'll use different colors. So I would normally just jump from here to that step, because I know I integrate each piece. All right, so that's how I would do it to skip some steps, because again, I integrate each piece, apply the correct formula for each piece. All right, the next one's number 33. And just for this video, I'll decompose it, so do it all steps. For all steps, I would write this as the integral secant squared theta d theta. And then plus the integral of negative sine theta d theta. I will make a comment that here our variable of integration is theta in this case. Every other example I've done up to this point, I believe it's always been x. All right, and you'll note the d theta tells you this. So we're integrating with respect to theta. Now the correct formula, so for secant squared, integrating secant squared is tangent, because the derivative of tangent is secant squared. Also, just based on our formulas, we have here integral of secant squared gives you tangent. And like I said, just based on the definition of an antiderivative, we know it's tangent because the derivative of tangent is secant squared. So this would be tangent, but I write it tangent theta since we're dealing with theta as our variable of integration. So for the other one, I could factor out the minus sign and focus on integrating sine. Well, we know the derivative of sine is positive cosine, but it's going to be negative cosine when you integrate. So it'd be tangent theta, then minus negative cosine theta. And again, we have two minus signs because there's a minus sign as part of the integral, and then the antiderivative of sine is negative cosine, so that's why there's the two negative signs. So we just change that to positive, so it's tangent theta plus cosine theta plus c. All right, and the next one is the last one for this video. Number 35 is tangent squared y plus 1. All right, and notice we have y as our variable of integration now. All right, so there isn't a specific formula that we've learned as far as integrating tangent squared. So note, we haven't learned a formula for integrating tangent squared. So I'm going to have to do something in order to use my known formulas. So we're going to have to rewrite the problem, or rewrite the integral, so we can apply our known formulas. All right, and then this is at this stage, I'll try to see, is there a trig identity or trig formula that I can use to utilize as tangent squared. All right, so yeah, is there a trig identity we can use that incorporates tangent squared? And that's where you could go on Blackboard. In Blackboard, you'll see a document that I have all of the trig identities, trig rules. I'm going to go ahead and write the identity that we're going to apply. And this is one of the Pythagorean identities. And the one I use, it's tangent squared of theta plus 1 is equal to secant squared theta. All right, why am I using that trig identity? Well, I can rewrite it so that it becomes secant squared, and we know we can integrate secant squared. All right, so that's what I'm going to do. So I use that identity. So our original problem had tangent squared of y plus 1 and then dy. So then I use this identity. I have the tangent squared of plus 1, and that's equivalent to secant squared. So I could write this as secant squared of y. And we know from our list of formulas, we know the integrating secant squared becomes tangent. All right, that's from our list of formulas. Also, like I said earlier, the derivative of tangent is secant squared. So that's another way of thinking about it. All right, so that's going to be our answer. All right, so that's one where we had to utilize some identity to rewrite the problem because it wasn't obvious as far as there's not a formula in our list of formulas that we can apply for the tangent squared y part. Now you might have tried using and converting into sines and cosines, but it might make it more complicated. So you might tried converting into sines and cosines. So when I took trig, my last resort was to convert everything into sine and cosines, but I'll just demonstrate just what that's going to do. So tangent squared, that's going to be sine squared over cosine squared. And then right now, we don't even have any formulas in our integration table that deal with sine squared or cosine squared either. Okay, and so you're going to have to do some rewriting, and then it's going to make things more messy. So you still have to do some rewriting. So there's more steps that you can use, and you're going to have to rewrite it and so that you can use the formulas that we've learned. And it might not even work out that way, but that's assuming that you could do that. So this is just way messier than just doing it the way I did it. And by first way, I mean using that Pythagorean identity. Because once you know that identity, it's just one step. You just write tangent squared plus 1 is secant squared, and then integrating secant squared to tangent y. All right, so that gives you some examples of trig indefinite integrals. Now, I will be doing another video, and then the next video is going to be talking about solving a differential equation. And I figured I would go ahead and talk about that because it is in the section, but also if you're an engineer, you're going to have to take a course called differential equations. And at least this part is going to give you a glimpse at what differential equations is going to be incorporating. But it's like a baby version, like baby preview of it.